Now that we have improved our workflow and all data is stored in the database, it's time to move on and implement user authentication. Before we start working with the Firebase API, we will work on storing users in our database. To begin with, I will create a registration form. I will get the markup from the mockup seen here. I will copy the form and put it into a new register.view page component. Next up, I will create some data to store the values of the inputs. I've found that wrapping the form's data in a form object works really well for me, especially when the initial values are coming down to the component using props. The form object will have a name, username, email, password, and avatar properties. Let's bind these properties to our inputs. When the form is submitted, we will call a method. Let's say register. I will create this method, and for now, I will just send the data to the console, since we don't have an action to store the user in the database yet. That's enough for the page register component. Now, we have to emit the ready event so that the page gets rendered. Cool. Let's create a route and check it out. Now, if we visit the /register page, we see our form. And if we type some values and hit submit, we see the form object in the console. Great. In the next lesson, we will implement an action and store the user in the database. It's time to create an action and store new users in the Cloud Firestore. Before we do that, let's review what the user object looks like. Each user has an avatar, a bio, an email, a last visited at timestamp, a name, posts count, if they've had any posts, registered at, a threads array, username, and then the lowercase version of their username. The reason for storing the username also in lowercase is because in the Firestore, it's a good practice to store key properties in lowercase since queries are case sensitive. So, from all of these properties, when we create a user, we can fill in the avatar, email, name, registered at, username, and username lower. Let's create our create user action. In the payload, we should expect to receive the email, the name, the username, and the avatar. Let's make the avatar property optional by setting it to null if not passed. Also, notice we're not getting the password here. We don't want to store a raw password in the Firestore, but rather we'll set that in the next lesson directly with the Firebase authentication. Let's also make the action async, since the call to the Firestore will be asynchronous. Inside the action, we can start by setting the current time to the registered at variable. Next, let's do the username lower variable. Because in Firestore, it's good practice to store the properties in lowercase to make querying by them easier. We will convert the email to lowercase before storing it. We could have done the same for the username, but it's nice to keep this as a separate property in order to keep the original for display. Next, we can group together all the user properties in an object and send it to the Firestore. For now, we will create a new user ref with an auto-assigned ID. But in the next lessons, we will use the Firebase UID coming from Firebase Authentication. Next, we'll use the set method to set all the user's properties. Now, we'll get a fresh copy of the user from the Firestore, as we've done with posts and threads. And then commit set item to store it in Vuex. Lastly, we'll return new user passed into doc to resource in case the code calling the action wants to directly access the new user. Cool. Let's dispatch our action from the register page. I'll also change the register method to async so that we can wait for the create user action to complete and then redirect the user to the home page. Let's give it a shot in the browser. When I submit the form, I'm redirected to the home page, which means that everything worked. We can confirm that by checking Firestore in the Firebase console. Nice. In the next lesson, we will integrate Firebase Authentication. Now it's time for the exciting part, integrating our registration form with Firebase Authentication. This way, we will create a Firebase user while at the same time storing the user object in the Firestore. While I'll walk you through setting up Firebase Authentication, if you'd like a more in-depth guide to using this service, we have a course on View School that you can check out before watching these lessons. It's linked in the description below. Okay, the first thing to do is to enable the email password provider in the Firebase console. You can do this by going to the Authentication tab and then clicking on Sign In Method. Now, we can register users in Firebase using a Create User with Email and Password function coming from the Firebase Authentication module. Remember that the Firebase Authentication service supports only specific user information. This means that we cannot store custom data, like threads or post count, to the user. What we can do instead is to register the users with Firebase and then store them in Firestore as we do now. For that, we have a couple of different options. The first option is to call the Create User with Email and Password function before dispatching the Create User action right inside of the Register page. And we'll have to import Firebase. Then we will call our action and pass it the unique ID of the created user. The ID of the user in Firebase Authentication is called the UID. Let's update the Create User action to use the past ID instead of creating an auto-generated one. Great, let's try it out in the browser. Now, in the Authentication tab of the Firebase console, we should see this new user. And if we look in our Firestore database, we can see that it's stored there as well. That's nice, though I don't really like coupling our components to Firebase. This coupling should be done inside the store. So, if you ever decide to switch to another authentication service, you only have to update the store and not all of the related components. So, one option here would be to extend the Create User action and call the Create User with Email and Password function before storing the user to the database. The drawback of this approach is that the Create User action would then be limited to only creating users with email and password in Firebase. So, if we want to reuse it when we register users with third-party providers, We would need to repeat this logic. What I will do instead is to create an action that will handle the logic that we have now in the register method. I will name this action register user with email and password. Now let's set the arguments and also use them to register and store the user. Back in the register page, we can call our new action, pass it the form data, and redirect to the home page when everything is done. We can also remove this import statement as our component doesn't rely on Firebase library anymore. Let's check it out in the browser. We can create a user, and we see that the user is stored as a Firebase user, and it also exists in the Firestore. In the next lesson, we will sign users in to our application after they have registered. When we register a user through Firebase, we know that we can access the user in the session, though our application is not aware that we are logged in because we are not updating the auth ID in the state. Thus, in the navbar, we don't see the logged in user. To sign the user in right after creating an account, we could update the auth ID here. This solution will work, but it will be temporary since this would run only when the account is created, and thus we lose the authenticated user right after refreshing the page. How can we make this a little more solid? Remember that our auth user getter requires that the user with the specified ID exist in the state, so we have to make sure that the user is fetched before updating the auth ID. Let's update the fetch auth user action to get the currently logged in user from Firebase. We can grab the user ID from the firebase.auth.currentUser object. With the ID in hand, we can now fetch the authenticated user from the Firestore, and then update the auth ID in the state. I'll also use optional chaining on the current user.uid. So that way, if there is not a current user, we can just return early. Finally, for this to work, we'll need to create the setAuth ID mutation. And at this point, we can get rid of that hard-coded auth ID in the state. To test drive our new action, we can call it after registering a user. I will create a new account, and then once I hit register, we should see the new user in the navbar. If I create a thread now, it will be assigned to the authenticated user. Though, as we expect, if I refresh the page, I am not authenticated anymore, since we are not utilizing the session Firebase has set for us. To fix that, we will use the recommended approach to get the authenticated user from Firebase, which is to use the on-auth state changed observer. First, I'll remove the action dispatch in the register user with email and password action. Now, we can use the on-auth state changed observer in main.js. So, when the auth state changes, if there is a signed in user, we will fetch them. In order to access the store here, we're using the store variable from where we've imported it previously. This is necessary in order to have access to the store outside of the View application instance. This should do the trick. Let's check back in the browser. This time, we are logged in, despite if we refresh the page or open the app in a new tab. This is great. At this point, the only way to sign in is by creating a new account, and there is no way to sign out again. In the next lesson, we will work on signing users in and out. In the last lesson, we logged the user in after registering them, but already registered users don't have a way to log in yet. Let's fix that. I will create a sign-in page component. And I will copy and paste the markup from the mockup. Next, I will add a form object to the data. And inside an email and a password property. Let's bind these data properties to the form inputs. When the form is submitted, we will call the sign-in method. Also, here I see that we have a link to create an account. Let's replace that with a router link. In the sign in method, we will dispatch an action to sign in. I will name this action Sign in with email and password. When the sign in succeeds, we will redirect the user to the home page. Here, let's also display an intrusive alert if something goes wrong. Finally, in order for our page to work, we have to omit the ready event. Let's implement the sign in with email and password action. Here, we will call the sign in with email and password Firebase function and return the promise that it returns. Because we have set up the auth observer, our application will automatically be aware that a user has signed in, so we don't have to worry about updating the state manually. Let's add a route for the sign in page. The sign out functionality is very simple. Let's create an action for that. Here, we will call the sign out Firebase function, and then we can set the auth ID to null. Even though we have the state observer, we'll commit the set auth ID mutation in here because it's not a good practice to commit mutations outside of actions. And also, there won't be a way for users to sign out rather than dispatching the sign out action. If you prefer to do these in the state observer, you can create an action and dispatch it when the user is null. Okay, now in order to sign out, I will add a link in the navbar that we will render if there is a signed in user. When the link is clicked, we will dispatch the sign out action. When a user is not signed in, we'll show links for registering or for logging in. All right, now we should be able to try out the whole flow. Since we're already logged in, first we'll use the sign out link to sign out. When we do, you see the logged in user's name and avatar disappear. Nice. Now we can log in again. Alright, now I'm signed in again, and you can see my user in the navbar. In the next lesson, we will work on the navbar dropdown to clean up the display of the sign in, sign out, and register links, and to learn about class bindings. In the previous lesson, we added some links in the navbar to control the authentication. If you take a look at the navbar component, you will see that we already have a link for signing out inside of the user dropdown. I will move our working link here and remove the condition, as the condition is already used further up in the DOM. And I'll change the class to the proper one for a drop-down menu item. According to this comment, to open the drop-down menu, we have to append this class. Let's do that to see how it looks. Okay, that's nice. To make this work dynamically, we can toggle this class when the user clicks on the dropdown. To implement that, we will use class binding. Class binding is a really handy feature of Vue.js. According to the guide, to dynamically toggle classes in Vue.js, we have two options. The first one is using the object syntax. In this example, the div will have the class active when the isActiveData is true. If isActive switches to false, the active class will be removed. So the class bindings are reactive. We can have multiple classes toggled dynamically by adding more fields to the object. So, in this example, the text danger class will also be added or removed conditionally. Notice the quotes here, where the class name contains a dash. Another way to dynamically toggle classes is using the array syntax. Here we have two data properties that are the names of the CSS classes. So, using an array in the class attribute, we can assign both classes to the element. This is very handy when you have the class names inside of your data. You can also toggle a class in the list conditionally using the ternary operator. On top of that, you have the possibility to use the object syntax inside of the array syntax. Let's get back to our code. First, I will add a data property. User dropdown open, so we know when the dropdown is actually open, and I'll default it to false. Now, in the dropdown element, we can bind the class attribute to an object, so we add the active drop class when the user dropdown open data is true. Now we need a way to toggle the value of the user dropdown open data property. We'll add a click event listener to the router link where our user name is displayed. And then we'll change the router link tag to an A tag instead, since we no longer want clicking on the user's name to take us to the profile page, but rather to toggle the dropdown. And we'll clean it up by removing the to attribute and adding a .prevent to the click event so that the browser will not try to follow the link. Since the username itself no longer links to the profile, let's reinstate the router link, this time around the View Profile item in the dropdown. Back in the browser, we can now open and close our dropdown. Sweet! Class binding is a powerful tool, as demonstrated here. You'll find yourself using it all the time. In the next lesson, we will implement authentication via third-party providers. Now that we've taken care of the user authentication, we can easily implement any of the third-party authentication providers that Firebase supports. I really love how powerful and convenient Firebase authentication is. The first thing to do when using any provider for authentication in Firebase is to enable it in the dashboard. We will be using the Google provider, so I will enable this one. Now, we can use the Firebase sign in with pop-up method to either create users or sign them in. I will create an action, sign in with Google, to get this started. First, we need to instantiate the auth provider that we want to use. In our case, the Google provider. Then, we can sign users in, either by redirecting the users to Google or using a pop-up. We will go with the latter, so we will use the sign in with pop-up function. Here, we need to pass the provider we want to use. If the authentication succeeds, we can access the authenticated user under the response. So, at this point, we know that we have an authenticated user, but we don't know if they exist in our database or not, because remember that we will call this action either when users sign in or when they register. Thus, we need to check our database to see if there is a user with the ID equal to the authenticated user's ID. The returned document object provides a property called exists. So, if the user registered just now, user.exists will be false. Thus, here we should store the user in our database. We can find the user info under the user object. Though the user object doesn't have a username, but we can use the user's email for that. Later, the user will be able to update the username in the profile page. Let's try to create the user. I will add a method to the register page component. and trigger it when the Sign Up with Google button is pressed. Now, over in the browser, I can register a new user with my Google account. Awesome. Let's also implement signing in with Google. I will create a method in the sign in page and call our sign in with Google action. Then we will call this method when the sign in with Google button is clicked, and we are good to go. I will log out, press sign in, and sign in with Google. Ta da! I'm signed in with my Google account. Unlike all of the other data fetched from the Firestore in the created or mounted hooks of the visited pages, the data for the user is fetched in the auth state changed event provided by the Firebase Authentication service. Because of that, we don't necessarily want its snapshot unsubscribed from on route change, like all the other data snapshots. In fact, because the snapshot is created in the auth state change event, but then unsubscribed from when a route in our app changes without ever being recreated, that means we'll never receive any real time updates to the authenticated user. You can see this issue in action if you create a new post. You'll notice the user's posts count does not increase. So, for the auth user, we only want to unsubscribe from the snapshot only when the auth state changed event has fired. That would make it so that once the user logs out, or if they log in to a different account, the browser would no longer receive snapshot updates about the previously logged in user. In order to accomplish this, the first thing we want to do is provide a place to store the unsubscribed function for the auth user snapshot. We'll create a property in the state called auth user unsubscribe. Then, we'll create a mutation in order to set that state. Next comes the tricky part. The fetch auth user action calls the fetch item action, just like all the other fetch resource actions. And the fetch item action automatically appends the snapshot unsubscribe function to be called on route change. So, how might we provide a different behavior just for the fetch auth user action? We could create a condition inside the fetch item action that checks to see if the resource specified is a user's resource. But this would apply to any user and thus would not function correctly. So maybe we add an additional check to see if the ID passed to the fetch item action is the auth ID. This would probably work fine, but I don't like how our generic fetch item function is now polluted with logic about a particular resource. Instead, let's put the responsibility of committing the set auth user unsubscribe mutation on the fetch auth user action where it belongs. We can do that by making the fetch item action accept a callback function to handle the unsubscribe. And we'll make it optional. If it's not provided, we can continue to commit the append unsubscribe as we did before. Then, in the fetch auth users action, we will provide the callback, which will commit the mutation. And we need to make sure to pass the unsubscribe to the handle unsubscribe function. Now that we have the unsubscribe function stored for the auth user snapshot, all that's left to do is to call it at the appropriate time when the auth state changes. We'll create another action to do that. I'll do it here under the unsubscribe all snapshots, just because it's related. I'll also check to make sure the auth user unsubscribe is set before we try calling it. Finally, I'll reset the auth user unsubscribe to null after it's been called. And then we can call it over in the on off state changed callback. Great, that should do it. Let's throw a console log in the on snapshot event in fetch item and make sure things are working as expected under the hood. Now we can log out and back in again. Let's open the console and clear it out so we can see a little bit better. And when we create a new post, it increments the post count correctly. And in the console, we see the console log for our user snapshot. If we make an update directly in the Firebase console, we'll see the console log again. But if we log out first and then do the update in the Firebase console again, the console log never happens. Perfect. Lastly, we'll remove that console log. And that wraps up the chapter on user authentication. The Firebase Authentication Service provides a straightforward way to manage users, as well as many third party providers, out of the box.